All right, we are back. So T-minus 1 lectures to go. Tonight we finish our look at iOS and some of the features that we've hinted at thus far and that might empower you to do some pretty cool things with your third and final project. In fact, looking ahead to exactly that, on Wednesday, August 7th, in lieu of lecture, we'll have an app party of sorts whereby we'll convene across the hall where labs usually are held. We'll bring in some snacks and food and whatnot, and you'll bring your laptops and or iOS devices, and the goal will be to spend an hour or so exhibiting each other's work and chatting and sort of debriefing how the semester went and showing off what you're hopefully quite proud of, whether that's your final project or either of the prior two. And leading up to that next Monday will be a couple of guest lectures. So I and all the TFs will be here, but we thought we'd invite a couple of friends. One is a fellow named Dan Armendariz, who used to co-teach this class and taught an Android aspect of it. What we thought we'd do is give everyone some exposure to what Android programming is like, what's similar, what's different, so that you can scratch that surface and see if that's a direction you might like to go in next. And we'll also have a friend of ours from Microsoft, Bob Familiar, join us to talk about Windows mobile programming, taking a look at how you might do it with C#, which is Microsoft's language for desktop and mobile programming, as well as how you might also do it using HTML5. So that'll be our final glance at the semester. And we'll also tie up loose ends with iOS and give you a sense of where you can go from here and what you might want to keep in mind so that once the training wheels are off, you can actually create some cool things on your own, if indeed of interest. So with that said, how would we go about making something like this? So we saw our first application involving Rob last week, and what were the features we implemented atop Rob's 3 photos last time? Yeah. Gestures. So we had a couple of gestures. We were able to swipe from left to right to move Rob from one side to the other, or from right to left in order to pan through his 3 Facebook photos. Thank you for sending him those Facebook friend requests so quickly, incidentally. And we also had one other feature that we implemented atop Rob's face, which was what? Alerts. OK, but we'd seen alerts before. How did we trigger that alert last time? Yeah, so touching down or a long press, where if you hold for a good second or two, that is a separate event that's fired that we caught in code, and we said, hey, stop that, or something similar. So we had 2 such gestures, but we didn't really do a couple of the more familiar mechanisms whereby I might, for instance, want to just move something around. Now, this is a little underwhelming on a backdrop, but because this is rectangular, you could imagine having images or shapes of some sort where it would make sense to actually move these things around. And in fact, where we'll end tonight is actually looking at how to do this programmatically. How do you create 2-dimensional graphics that move in response to user actions or just move around on the screen on their own? So this is a translation of sorts, moving up, down, left, or right. But what you can also do in the simulator, if you hold Option, you'll see that my cursor is flanked by a second circle, and these represent 2 fingers. So you can actually mimic the idea of pinching, even though you can't touch your laptop screen. And if we do this, we can zoom in on Rob's denim shirt atop denim shorts, or we can zoom out until this image gets super, super small, much like you might pinch and zoom in Maps or Google Maps or the like. So how would we go about implementing something like this? Well, let's take a look at some basic building blocks, and we'll see some similarities and some differences. This is the more complex of the ones we looked at last time. So app delegate is a good place to start. Main.m never seems to have anything of interest, so we won't even glance there for now. Does anything look anomalous, new, different in this file versus past examples? This is the appdelegate.h file. No, nothing magical there. This is just a boilerplate code that you get with the single view application. How about the .m file? If I scroll down, looks like this is the only method. Anything interesting, new, or different there? No, but it seems to be this guy, as usual, that's kickstarting the process by assigning to view controller a newly allocated view controller. It's being initialized with the nib view controller. There's no file extension, but recall that that's by default referring to the .xib file that we've had for some time now. And then finally, we're making it the key window and visible, which means foreground, whatever the contents of that nib were. Well, what is that nib? Let's take a look in the xib file. And we see Rob. For a moment, it flashed for just a moment, because that's actually because there's a couple of objects layered on here. And we can see this if I zoom in and I click on View. Recall that View, a UI view, is the rectangular shape that we've typically laid down. And we have an image view. So this is actually a different class that we haven't seen before. If I pull up the inspectors over here on the right and choose my identity inspector, you'll see that this is a UI image view. And this is like a container for actual images. And those images, as we'll see in a second, are going to take the form of UI image objects. So let's actually see how we now started listening for events atop Rob's single photo there. Well, first, let me expand supporting files. There is the photo, rob.jpg, that I configured here. And indeed, if we go back to the inspector, just to confirm, let me go up to the attributes inspector. The fact that it says rob.jpg in the top right corner, that just means that's why the image view is displaying that image. So no magic there. So the complexity must be in this guy. No, not in the viewController.h, or the one remaining candidate, viewController.m. So let's see if we can't wrap our minds around what's going on here. First, a couple of teasers. So this up here is an example of what? What Objective-C construct? Yeah. Yeah, so it's a category. It's a nameless category because there's nothing inside the parentheses. And it's a way of sort of creating the illusion of privacy in Objective-C, whereby we have apparently a private data member called cgPoint _ translation. And cgPoint is actually something from the core graphics library. So CG, core graphics, this is referring to Apple's support for two-dimensional graphics. And we'll see that this is actually a primitive of sorts. It's not actually an object, because a lot of the code you're about to see in two-dimensional graphics actually has its origins in C. So we're going to start seeing some commingling of Objective-C and C, which is the language, recall, you took a look at when Rob was at the helm a few weeks back. So we have a couple of properties in here. One is a float called scale, and one is an image view, a UI image view called image view. And we'll come back to that in just a moment. We seem to have a couple of private methods in here. One is called handle pan, so moving left, right, up, down, and handle pinch, which is the two-finger gesture. So that's just setting the stage now to listen for those events. And if we scroll down here, what seems to be going on? Well, when is this? Yeah.
Sorry, if we go back,
Uh-huh.
is there any reason for using an instance variable instead of a property for cgPoint?
Is there any reason to use an instance variable rather than a property? It's a good question. What was the motivation for this? You can still do primitives. Short answer, I don't think. Yeah?
If you're using instance variable instead of a property, this will prevent outside classes from accessing that property.
Yeah, no, that's true, but I'm at the same time not doing the same when it comes to scale in image view necessarily. Let me think about why we did this the way it is, but short answer doesn't matter in this way. We don't need that functionality of the setter or getter. But a good question. I'll come back to it. All right, so init with nib_name. This is the first method that's invoked here. And the init with nib_name seems to be preparing a few things. So one, it's calling the superclass, which is actually doing the loading from that .xib file, which is the normal default case. And then we're apparently setting a property called scale to 1.0. And that's just a default reminder that by default, Rob is at normal scale, 100% X, 100% Y. There's no zooming in or out. And then translation X and translation Y is referring, oh, this is why. So the reason that I'm using the, so cgPoint is actually something called a cstruct, which you may recall glancing at in C, which is kind of like an object that doesn't have methods associated with it. It's just a container for data. So problems actually arise because Apple chose to use the dot operator when it came to properties, but the dot operator is also used for structs. So doing it this way ensures utter clarity as to what's going on. In this particular line here that's highlighted in blue, I'm accessing the X member of the cgPoint struct, and I'm doing then the same for Y. So things get a little messy if you start commingling the two features. Came back to us. OK, so translation X, translation Y. A translation is just a shifting, up, down, left, or right, or some diagonal. And this is implying by default, Rob has not been shifted up, down, left, or right. He's just smack dab in the middle of the screen. So these are our initializations of variables. So now a few things are going on. There's a handle pan method, apparently. There's a handle pinch method. There's a viewDidLoad. Let's actually go to viewDidLoad down here. And let me hide this so we can focus on just these three. viewDidLoad, recall, is loaded once the nib has been loaded and the view is ready to go in memory. And as the comment suggests, we're listening for two things: a pan from left to right, or top to bottom, or top down, or a pinch with two fingers. And this is code quite like we saw last week. We initialize a certain type of recognizer. We initialize it with a target that has to be self in this case. Self is referring to an object of what type at the moment? Who is self? the view controller. So presumably whatever method we are telling the recognizer to invoke when panning happens is somewhere in this class, and indeed it was higher up in the file. And then this selector syntax is just our way of saying call the method handle pan, and colon just means it takes that one argument. And then over here, what are we actually doing? We'll notice that self.imageView is our property that maps via